Imagine a non-technical professional trying to build a complex software system like a supplement medication interaction checker. Traditionally, this would require a specialized engineering team and weeks of development time. However, by using Claude Code, this individual was able to spin up four distinct AI agents: an architect to research FDA guidelines, a builder to write the API, a validator to build test suites, and a scribe to document the code. Working in parallel, these agents completed the entire project in just 2 days. This is where the real world impact of Claude. It transforms a single user into a fully functional parallel processing engineering team. So, how exactly does this work? Let's take a step back and first look at what Claude actually is. Claude, specifically accessed through tools like Claude Code and Agent SDK, is an advanced AI-powered coding assistance and runtime environment. It goes far beyond a simple chatbot. Claude can autonomously read your entire code base, execute terminal commands, edit files, manage version controls, and even connect the external applications using the Model Context Protocol. It is available directly in your terminal, IDE, desktop app, or even your browser. Now that we understood what Claude is capable of as a baseline, let's get into what Claude agents and skills are and how they unlock these powerful parallel workflows. Claude agents are autonomous systems that can plan, execute, verify, loop, and delegate tasks with varying level of human oversight. They range from simple single session sequential flow to fully autonomous headless agents that run on a recurring schedule without any human intervention. You can also orchestrate multi-agent teams where a lead orchestrator agent breaks a massive task into pieces and delegates them to specialized sub-agents working simultaneously in parallel. Now, agent skills are reusable file system-based modules that give Claude domain-specific expertise. Instead of cramming complex instructions into every single prompt, you can package instructions, metadata, workflows, and even reference material into a skill. Claude automatically loads these skills on demand when they are relevant to the task. They act like an onboarding guide for a new team member, allowing Claude to become a specialized in tasks like PDF extraction or even database migration without wasting upfront context window space. Now, if you want to master the AI systems powering Notebook LM Ultra and take your generative AI skills into enterprise level, check out the Advanced Executive Program in Applied Generative AI from IITM Parvatak and Simplilearn. This 4-month live online program is perfect for students, educators, IT professionals, and teams who want to lead in agentic AI and even generative AI development with 70 plus hours of hands-on labs using tools like Copilot, Azure AI Studio, ChatGPT, DALL-E, and Hugging Face. You'll master agentic framework, MCP protocols, LLMS prompt engineering, RAG application through 7 capstone projects and 15 plus real-world case studies, plus get a 2-day campus immersion at IIT Madras Research Park, exclusive masterclasses from IITM faculty, and Microsoft badges from Azure, AI Fundamentals, and Copilot certifications. Simplilearn's job assistants include AI resume optimization, mock interviews, one-on-one career mentoring, and exclusive hiring opportunities from top companies. Earn Elite certification from IITM Parvatak Technologies Foundation plus startup incubation eligibility. Hurry up and enroll now. The link is given in the description box below and in the pinned comments. Before we begin, here's a small question for you to answer. Which concept allows Claude to reuse structured knowledge without repeating prompts? Is it agents, skills, tools, or is it workflows? Let me know your answers in the comment section below. Also, if these are the type of videos you'd like to watch, then hit that subscribe button. Now let's dive into the video. So now that we understood what Claude can do, let's start with a very important concept, which is Claude Skills. Claude Skills are reusable file system based modules that gives Claude specialized expertise. You can think of them like an onboarding guide for a new team member. Instead of explaining the same task again and again, you package all the instructions once and Claude can reuse them whenever needed. Now, why do these skills actually matter? The main reason is efficiency and consistency. Skills allow you to package entire workflows along with context, best practices, instructions, and even optional files. So instead of writing long, repeated prompts every time you want Claude to perform a task, you just rely on predefined skill. This makes your workflow much cleaner and faster. You're not starting from scratch each time. You're building something structured and reusable. If you look at the components of a skill, it typically includes things like workflows, context, best practices, instructions, and optional files. Together, these elements give Claude a complete understanding of how to perform a task properly. So, in simple terms, Claude Skills helps transform Claude from general assistant into a specialized expert, one that already knows how to handle specific tasks without needing repetitive guidelines. Let's break this down further with some key points and some analogy. First, Claude skills are reusable modules, which means once you create a skill, you can use it again and again and get consistent outputs. This ensures consistent outputs across repetitive tasks, especially when you're working on structured tasks where consistency matters, like code generation, data processing, and also documentation. Second is skills combine multiple elements together. Instead of just giving a prompt, you are providing context, instructions, and workflows in one place. This gives Claude a much cleaner understanding of what needs to be done and how it should be done. Third, and probably the biggest advantage, they save time. You don't have to keep writing long, repetitive prompts. Once a skill is created, you simply reuse it, which makes your entire workflow faster and more efficient. Now let's understand this with a simple analogy. A prompt is like one-time instruction. You tell Claude what to do and it responds for a specific instance. But a skill is like reusable playbook. It already contains all the instructions, structure, and even best practices. So instead of explaining everything again, you just use the playbook. So overall, skills helps you move from one-time instruction to structured, repeatable systems, which is a big step towards building powerful AI workflows. Now let's talk about an important concept called progressive disclosure. Claude loads skills in stages instead of all at once. Instead, it loads information in stages, which helps save context space and improves efficiency. The first stage is metadata. This is the basic information about the skill, what it does, and when it should be used. Claude reads this first to decide whether the skill is relevant to the current task. If the skill is relevant, Claude moves to the second stage, which is instructions. These are the core guidelines or steps that tell the Claude how to perform the task properly. At this point, Claude starts understanding the actual workflow. Finally, we have the third stage, which is resources or even scripts. These include additional files, tools, or even scripts that may be required to complete more complex tasks. These are only loaded if absolutely necessary. So instead of loading everything upfront, Claude follows a step-by-step loading approach. The key idea here is very simple. Load only what's needed when it's needed. This makes the systems more efficient, reduces unnecessary memory usage, and ensures that Claude focuses on relevant information. So, progressive disclosure is what allows Claude to stay both powerful and efficient at the same time. Now, let's clearly understand the difference between metadata and instructions because this is a key concept in how Claude skills work. Starting with metadata, this is what Claude looks at the first. At startup, Claude only loads a tiny summary of the skill, including its name and short description. The goal here is to not perform the task but simply to decide whether the skill is relevant. So, metadata helps Claude answer one question: should I use the skill or not? It doesn't contain detailed steps, it's just enough information for decision making. Once the Claude decides that skill is relevant, it moves to the next part, which is instructions. Instructions are much more detailed. Claude loads the full skill file at a stage, which includes step-by-step guidance, workflows, rules, and best practices needed to actually complete the task. So, while metadata is about decision making, instructions are about execution. Think of it like this: metadata is like reading a title, and the summary of the book is decided if it's useful. Instructions are like reading the full book to actually learn and apply something. Metadata helps Claude decide, and instructions help Claude perform the task. Understanding this separation is what makes skills both efficient and powerful. Now let's compare pre-built skills and custom skills and understand when to use each. Starting with pre-built skills, These are ready-made skills designed for common tasks and workflows. You don't need to create anything from scratch. The setup effort is very low, so you can start using them immediately. However, because they are standardized, they are the best suited for general use cases. For example, tasks like working with PowerPoint, Excel, Word, or even PDF workflows, things that are commonly across many users. In contrast, custom skills are designed for specific needs. These are designed by the users for specific projects or company needs. Unlike pre-built skills, they require more setup effort because you need to create and configure them yourself. But the advantage is flexibility. Custom skills are highly tailored, meaning they can match your exact requirements. For example, you can build a sales report generator, a legal document reviewer, or even an internal onboarding guide. So the trade-off here is simple. Use pre-built skills for fast common tasks and create custom skills for unique high-impact work. Choosing the right type of skill depends on your use case and how specific your requirements are. Now that we have understood skills, let's move on to Claude Agents. Claude Agents are autonomous systems that can plan, execute, verify, repeat, and complete tasks while working towards a specific goal. Instead of just responding once like a chatbot, agent follows a step-by-step process to get the job done. Let's walk you through this flow. First is plan. The agent starts by understanding the goal and breaking it down into clear, manageable steps. This is where it decides what needs to be done. Next is execute. Here, the agent takes an action using tools, skills, and available resources to perform the task. After that comes verify. The agent checks the result for accuracy and quality, making sure the output meets the required goal. Then we have repeat. Then we have repeat. If something is not correct or needs improvement, the agent refines the approach and learns repeating steps as needed. Finally, we reach complete. Once everything is accurate and meets the objective, the agent delivers the final result. So, unlike traditional system, agents don't just stop after one step. They continuously evaluate and improve until the task is done perfectly. In simple terms, Claude agents act like a self-managing system that can think, act, and refine its work, bringing us closer to fully automated workflows. Now let's understand how agents actually operate in real scenarios using something called as the agent loop. Agents don't just perform a task once and stop. They work on a continuous loop, improving their output until the final goal is achieved. It starts with plan. The agent takes a high level goal and breaks it down into smaller actionable steps. This gives direction to the entire process. Next is act. Here, the agent takes the action by interacting with different tools. This could include calling external tools, executing commands, and also using available systems to gather information and perform the task. Then comes verify. After taking action, the agent checks the results against the original goal. It evaluates whether the output is correct, complete, or even useful. If the result is not satisfactory, the agent enters the loop phase. It determines what needs to be fixed and continues the cycle without requiring constant human intervention. This loop continues until the agent reaches a point where the goal is fully achieved. Also, notice the role of the tools here. Agents can use things like Bash, file systems, and web search to extend their capabilities beyond just generating text. So, overall, the agent loop enables a system where the agent can plan, act, verify, and improve continuously, making it far powerful than a single step AI interaction. Now, let's look into another powerful aspect of agent, which is built in tools. AI agents are not limited to just generating responses. They come with built in tools that allow them to interact with real world and perform actual actions. Let's go through some of these out of the box tools. The first one is read and write files. Agents can directly access your systems to read existing files and write new ones. This means they can edit code, generate documents, and update data without you manually copying and pasting anything. The second tool is running terminal commands. Agent can execute terminal commands and scripts, which allows them to perform tasks like installing packages, running programs, or even automating workflows. This makes them extremely useful for development and system level operations. The third tool is web search. Agents can search the internet to find real time information instead of relying on pre trained knowledge. They can fetch updated data and use it to improve their outputs. So, these tools extend the capabilities of agents from just thinking and responding to actually doing real work. In simple terms, built in tools are what allow agents to move beyond conversations and take actions, making them far more practical and powerful in real world applications. Now, let's focus on the advanced tools that take agent capabilities to the next level. The first advanced tool is computer use. This allows the agent to interact with your system just like a human user. It can see what's on the screen, move the mouse, and even type using the keyboard. So instead of only working through code or commands, the agent can actually navigate applications, click buttons, fill the forms, and perform UI based tasks. This is especially useful in scenarios where automation through scripts is not possible or even practical. The second advanced tool is MCP or Model Context Protocol. MCP acts as an open standard similar to USB-C port that allows agents to connect with external applications and data sources. Through MCP, agents can integrate with tools like Google Calendar, Google Drive, Slack, GitHub, or even internal company datasets. This means the agent can not only access data but also interact across multiple platforms seamlessly. So while basic tools help agents perform actions locally, advanced tools like computer use and MCP allows them to operate across systems and environments. And that's the key idea. These tools enables agents to go beyond simple tasks and become fully capable real-world digital assistants. Now let's look at the 5 structured patterns used in Claude Agents. These patterns define how agents are designed and how they operate in different scenarios. The first one is sequential flow. This is the simplest pattern where tasks are executed step by step in a single session pipeline. It works for bounded tasks where the process is clearly defined. Next is the tool used pipeline. Here the agent uses external tools or even APIs to complete the tasks. This is useful when the agent needs to interact with live data or external systems. The third pattern is sub-agent orchestration. In this case, the main agent delegates tasks to multiple sub-agents working in parallel. This is ideal for complex tasks that can be broken down and handled simultaneously. Then we have human in loop. This pattern includes human checkpoints within the process. The agent can make decisions and perform actions, but critical steps are verified by humans, especially for safety or even accuracy. Finally, there is a fully headless. These agents run in a background without human intervention. They are event triggered or even scheduled and continuously perform tasks automatically. So these 5 patterns provide different ways to design agent workflows from simple step-by-step processes to fully autonomous scalable systems. Now let's look at the 5 workflow patterns that define how tasks actually execute using agents. The first is prompt chaining. Here, a complex task is broken down into a sequence of smaller prompts where each step builds on a previous one. This helps in maintaining clarity and ensures that each stage is handled properly. The second pattern is routing. In this approach, the task is directed to most of the suitable path or expected based on the input. So instead of one system doing everything, the request is intelligently assigned to right handler. Next is parallelization. This allows multiple tasks to subtasks to run at the same time, which significantly improves speed and efficiency. Instead of waiting for one task to finish, everything runs simultaneously. The fourth pattern is orchestrator workers. Here, a central orchestrator is responsible for planning and delegating tasks to multiple worker agents. Once the worker completes their paths, the orchestrator combines the results into a final output. Finally, we have evaluator optimizer. This pattern focuses on continuous improvement. The system evaluates the output, identifies areas for improvement, and keeps refining it until the desired result is achieved. So overall, these workflow patterns help in structuring tasks in a way that is efficient, scalable, and intelligent depending on the complexity of the problem. So to summarize, we started by understanding what Claude is and how it goes beyond simple chatbot. We then explored Claude Skills, which helps structure knowledge into reusable modules, and Claude Agent, which brings automation through planning, execution, and continuous improvement. We also looked at how agents use built-in tools to interact with real-world systems and how different patterns and workflows allows us to design solutions that are scalable and efficient. The key takeaway here is that it is not just about using AI, it's about building systems with AI. As these technologies continue to evolve, the ability to design and work with agents will become an essential skill across industries. So, whether you're a developer or non technical professional, understanding these concepts put you one step ahead in the future of AI driven workflows. For more such videos, subscribe to Simplilearn. Until next time, thank you and keep learning with Simplilearn.